The key point here is to strike, as if you were spraying, an arc into the inner part of the fillet and fuse the two base metals uniformly. While rod manipulation can be linear in principle, allowing the rod tip to weave slightly makes it easier to get the desired timing for upward manipulation. Beware of making the arc too long, because this will cause undercuts. Next, you'll practice depositing a weaving bead. Set the current at 150 amps and adjust as necessary as you proceed with the welding practice. As with flat position welding, manipulate the rod a bit faster in the center area and slow down at the weld toes. Note, however, that droops are likely to occur unless the manipulation speed in the central area is faster than that used for flat position weaving. Also bear in mind that manipulating the rod very slowly at the weld toe areas, as you would for flat position welding, may result in a scale-like bead. This should be avoided. Try to maintain an optimum pitch of upward motion, not too large, not too small. Given the upward motion, too small a pitch could result in droops or overlaps, which should be avoided. When manipulating the rod, make sure that it's always constantly moving upwards. Avoid repetitive movements over the same area. Shown here is the equipment required for TIG welding. TIG welding power source. This is a common type of manual TIG welding torch. Argon gas, the shielding gas, is contained in cylinders under extremely high pressure. For this reason, it cannot be supplied directly to the welding torch. A pressure regulator is used to lower the pressure to that suitable for welding. The regulator also maintains a certain amount of pressure even when the cylinder's internal pressure drops as the gas is depleted. The gas flow controller is designed to optimize the flow of gas coming from the torch nozzle. The remote controller is designed to allow handy control of welding conditions, such as welding current, pulsed current, and crater current. The TIG welding machine has functions peculiar to TIG welding, so you must set each function properly. The gas pre-flow function prevents oxidization of the tungsten electrode and base metals by letting the shielding gas flow from the torch nozzle before the arc starts. Pre-flow time is the length of time that elapses after the switch of the torch is pushed, the shielding gas begins to flow, and the arc is generated. This can be adjusted in units of 0.1 of a second using a timer provided on the welding power source. Pre-flow time is usually set in the range of 0.3 to 0.5 of a second. It's customary with TIG welding to begin the arc without bringing the tungsten electrode into contact with the base metal. A high-frequency generator circuit is used to create the arc. High-tension, high-frequency voltage is applied beforehand between the electrode and the base metal, inducing arc generation. Not only do craters mar the bead's appearance, but they may also lead to cracking and other defects, so craters should be filled properly. This operation is known as crater treatment or crater filler. Many TIG welding machines are fitted with a function to facilitate crater treatment by downslope current control, that is, lowering the welding current to a preset crater current at the weld end. It's advisable to use this function for crater treatment. Set the crater filler current about 30% lower than the welding current. Contrary to pre-flow, gas post-flow protects the still-hot electrode and base metals from atmosphere-induced oxidation by allowing the gas to continue flowing for a certain period of time after the arc has been discontinued. The duration of post-flow can be set across a wide range, from a minimum 5 seconds up to a maximum 30 seconds, according to the welding current and electrode diameter being used. Here we'll show you how to prepare for TIG welding. For this exercise, we'll use stainless steel plates of a moderate size, 3 mm or so in thickness. Cleanse the groove faces and their vicinity using organic solvent like acetone. Prepare tungsten electrodes. It's important to polish the tip of the electrode into the proper shape. Here's a yardstick for electrode extensions relative to the joint shape. If electrode extension is too large, gas shielding will not function properly. If electrode extension is too small, the weld pool will be hidden behind the nozzle, resulting in poor operability. In principle, filler rods should be of the same material as the type of base metals to be used. Prepare a dust respirator, a helmet with shield plate, and leather gloves for welding, and fit them properly. Rubber-soled leather shoes are recommended. Since specific power source operational procedures vary according to the welding machinery being used, please follow the instructions provided in the operating manual attached to your particular welding machine. Here are operational procedures for welding with crater treatment. Set the crater filler switch on the power source to with. In this state, an arc will be generated when the torch switch is engaged, but arcing is not extinguished even when the switch is released. As you approach the end of the weld, press the switch again and the crater filler current is engaged. Crater filling is carried out by a process known as downslope, when the welding current is switched to the lower crater